Okay, so the last problem in this set of notes are piecewise defined functions. And to graph a piecewise function, so to graph a piecewise function, each equation over the specified um, interval, graph, I should say, I'm sorry. To graph a piecewise function, graph each equation separately over the specified interval. So this is just one function, but it has two equations, okay? And that's why we call it a piecewise function, because it's broken into pieces, all right? And the way that I explain this, before we draw the graph, I want to get some information. And so here, notice on, I think I did this with you all when we were talking about just inputting values into piecewise functions. So we're going to do the same thing here. So we know one breaks up. There's always a value or values that breaks up your piecewise function, that breaks your function into pieces. In this case, one is that number. Okay. So one, actually, I want to put some more room there. Okay, so here one is separating our function, and we're going to include one here and all values to the left. So all values to the left are included in the first function, and then an open circle. Remember, a closed circle means you include the number. An open circle means you don't, and that's to the right. Okay, so that now notice that I didn't give you any values, right? That's because you can choose any values you want. Okay, you could choose any values you want. So we're going to make a little table, and my advice is to pick three values in each section. Okay, and so we're going to have x and f of x. All right, and so let's just pick some values. So for the first one, we can pick, of course, 1, we can pick 0, we can pick -1. And then for the second one, we can pick what, 2, 3, 4, okay, for our values. And so when x is 1, f of x, so that'll be 2 times 1 plus 3, so that's 5. When x is 0, that's 2 times 0 plus 3, which is 3. And again, I hope you guys understand we're using the first function because these values belong to that first equation. I'm sorry, not function, that first equation. And then -1, 2 times -1 plus 3, that equals 1, okay? The rest of these values go for our second equation. So when x is 2, we'll have -2 plus 4, which is 2. Then we have -3 plus 4, which is 1. And then we have -4 plus 4, which is 0, okay? So we have points to plot. Let's look at the graph. So I'm going to go to the graph now. Okay, so now in terms of the graph, so let's just plot these points, okay? And I just rewrote the points. So we have 1, 5, so 1, 5 is there. I don't know why my stylus doesn't want to work there. 0, 3. Let me see if I can do something else. No. Wait, hold on. Okay, so I've plotted the points already. So we have the points plotted, okay? And I made this dotted red line. This is an invisible fence. So you want to think of a piecewise function as a neighborhood. And if you live on one side of the neighborhood, you don't cross over to the other side. So we have two neighborhoods, and the fence, the invisible fence, is broken up by whatever's breaking up our piecewise function. So in this case, that 1 is breaking up our piecewise function, right? So this is actually the line x equals 1. This is a visible fence. So if you were to draw this, write this in pencil. If you were to graph a piecewise function, write this in pencil, and then once you're done with your function, erase it. Okay. And so to the left again, values to the left of 1, including 1, are with that first equation, right? So that's on your invisible fence. The only point that should be on there is that 1, in this case 1, 5, right? And then so the graph of that's going to look like that. Okay, going down. And then the graph of the other side, we have that part, right? But we're missing because it doesn't include, so going back to this, it's all values x is greater than 1, right? So it doesn't include 1, but 1.000001 is included on that graph. So we're missing all this right here needs to be included on our purple equation. And so in order to do that, and this is where some students have some issues, so we're going to go over another example in class of a piecewise function, but really see if you can understand what's going on. So although 1 isn't on this function, if it were on the function, where would it be? Well, if 1 were on this function or in this equation, then when we plugged in 1, we would get what? 3. So 1, 3 is where it would be if it were on this function, but it's not. However, because we want to make sure we get every other value after 1, we have to go to 1, 3 on the graph and make an open circle to represent again that we don't include the value. Okay, we're not including the value. And then we have our piecewise graph. So this is the graph. So we're done with the notes in this section. Make sure, again, you go over it. I'll post some homework probably on Monday or Tuesday. And then we'll continue from here on Wednesday.